here at ASHRAE we have a program of distinguished lecturers, people who literally circumvent the globe many times around to give their wisdom and their knowledge to all of our sections and chapters that exist around the world. We're delighted and privileged to have Mr. Dennis Knight come to join us, and he's just been mic'd up that so Dennis is going to give us a view on BIM in USA style, to see what we think of it in comparison to maybe our own thoughts and views on BIM and how successful it's been, or unsuccessful it's been maybe, in the UK. So if you're good to go, Dennis, so
sure.
You take it away.
Can everybody hear me? How about that? Well, good afternoon. Everybody awake? Yeah? Okay. All right. Well, first, I guess you'd say I've come across the pond, and it's been a great trip so far. My wife Cheryl's up with me. I want to thank ASHRAE UK Midlands, SIBSI and ABIPSA for asking me to come over and participate in this. I had the privilege of meeting with the Glasgow section yesterday for their very first meeting, which is great. The other thing is just, wow, I'm not going to talk about algorithms and run software demonstrations today, because you've certainly had a host of some of the best in the world at developing software for building performance analysis. I'm trying to move away from energy simulation, because I think at the end of the day, whole building simulation, whole building optimization is more about energy, and we'll talk about that a little as we go along today. I'm going to skip these. These are just to tell you that these presentations are AIA and USGBC accredited. So we're going to focus on integrated building design, building information modeling, the project delivery process, and I'm going to talk a lot, I think, about process today. How many design engineers in the room? We got a few? Okay. How many researchers? All right. How many students? All right. All right. Well, you are the future. Okay. How about this guy right here? Anybody ever feel this way? Yeah? Maybe with the first email or tweet or text message you got this morning? There's always a crisis. There's always some kind of drama, especially in construction, if that's the profession you're going in. And as Yi said, not only in our software programs, but just the sheer process of building something, there are so many variables. And there's a saying that, all models are wrong, some are useful. It is almost an intractable problem to tie down one answer to anything. And I see you practitioners out there, and I've been guilty of it. I've been in the business now over 40 years, of giving an owner a single EUI, a single cost estimate, a single budget, and you never hit them. Sometimes you're close, even with calibration. So I call this guy, he's been around in my presentations for 10 or 15 years now. He's the school of hard knocks. And just as Yi said, you've got to just sometimes do some things, figure out what works, what doesn't. If you're thinking in probability terms, it's a Bayesian term called priors. You've got to build some history, right? And believe it or not, every single person in this room, and this is one thing I want you to leave with today, that every one of you here is already an expert at something. You've got something useful to say and share with the person sitting next to you. Okay? That leads me to my favorite quote from a book, and it says, "Our lives succeed or fail gradually, then suddenly, one conversation at a time." And while no single conversation is guaranteed to change the world, a marriage, a business, your life, it can. The conversation's the relationship, right? And that's what collaboration amongst SIBSE, ASHRAE, ABIBSA, students, software developers, engineers, that's what our organizations are about, to bring us, this knowledge pool together, have these conversations, share a little bit of knowledge, let somebody have an aha moment, take it and run with it, find out what didn't work last time, and improve. Go through a continuous improvement process. So I'm going to talk a lot about process today. Now, this little graph here, let me see if I can't use the pointer and stay coordinated here. I'm not a gamer, so I can't use both my left and right hand at the same time. So, I mean, just looking at our progress since the printing press and the average gross domestic product. Now, that doesn't mean our lives have gotten any better because of technology. Some have, some haven't. But it's been exponential since Mr. James Watt up there in Glasgow improved the steam engine, and the printing press began to allow us to assimilate, organize, and disseminate our knowledge pool, what every one of us have in our brains that can be shared. This is a good book if you hadn't had a chance, if you are a researcher and you want to start thinking about some uncertainty and how much noise there is in the data that's out there. It's called The Signal in the Noise by an author named Nate Silver. I do recommend it. So we've already talked about that. Some of the things we're going to talk about are BIM, integrated design. A little bit about my experience. Throughout my career, I've been fortunate to be able to own several companies, and one being a MEP design, build, construction company and a general contractor, but also manage an architectural firm, and now as I work toward using this gray hair to retire, I'm doing commissioning and trying to lend my experience to design teams and design assist role to help avoid some of those lessons learned from my School of Hard Knocks guy. All right? So, very first thing I want to do is make a shameless plug for the ASHRAE Building Performance Analysis Conference, formerly known as the Energy Modeling Conference. Anybody here been to it? All right. Way to go. All right. Annie Marston was here. She had to leave. She had to catch a 4 o'clock train. Some of you may know Annie. She lives here in the UK. Annie's actually the chair of a real special feature of the conference called the Lowdown Showdown. Did Andrew have to leave, or David Cotton? Hey, Andrew. David, you still here?
Yeah.
All right. I know those two guys have been there because they have championed a team in this modeling challenge competition in past years. I wanted to go through and show you again, this conference is primarily focused on practitioners and giving practitioners a way to learn something about how things are done in the building performance analysis arena and take back a best practice at the end of this conference. But it doesn't mean that it's a shutout for researchers and software developers. Biggest thing, this is the 6th conference. These challenges have been focused on the developer and the practitioner working together to find better ways to improve their software, to actually allow it to do the things the practitioner has done. And I know David and Andrew have interviewed many a practitioner to try to refine and hone their software to provide the answers we need. So last year's challenge, I just want to give you, it was a 50,000 square foot outpatient clinic located, we picked the location. Again, every time we do something, I'm amazed, we try to define a way that it can't be gamed, okay? But of course, just like any other solution, that's probably an intractable problem, right? As long as the human mind's creative, somebody's going to find a workaround, and workaround's a big buzzword at that competition. But I wanted to show you some of the creative things that we did. I mean, after we said they had a baseline EUI, we gave them that, and then from that point on, they were free to use that baseline to try to get to net zero. You can probably infer from some of the software, the team names, what software tool they were using, but I won't tell you what they were. But we had some great creative solutions, and these are modelers, okay? Some practitioners as far as design engineers. One team had an architect. This one right here, that's Annie's team using Energy Plus right out of the box. Annie doesn't use a graphic user interface, and she can make Energy Plus sing. So if you haven't got to know her, she's a great resource over here for any of you doing modeling. She is the chair of this year's conference, and she's chosen to take a existing building in Washington, D.C. this year. And we have right at 100 people signed up with 10 teams this year. This year, they're not software developer-driven teams. They are actually led by practitioners who volunteer to work with a group between now and the end of September on the challenge. And then come in, everybody does a poster, and then we evaluate and go through first round of judging, and the top 3 to 5 are asked to present. They're given 15 to 20 minutes apiece to present. And then we take a half a day, just like this room right here, of Q&A from the practitioners and developers in the audience to have a conversation, just like I mentioned getting started, so we can learn from each other. How did you do this? What was your workflow? We're not looking for a specific outcome. Although they're graded on it, we want to know who's got the best, most creative way of using these tools, whether it's one tool, multiple tools, integrated tools, interoperable tools. So it's that's a plug for the conference. It's available virtually as well. So, and every other year it's a joint conference with ABIPSA, and we had 2 research tracks as well as practitioner tracks, so that we can bring the researchers and the practitioners together, so the researchers can get ideas from the practitioners of areas of need, and the practitioners can kind of see, well, these guys are starting to work on solutions we need to the problems that need to be solved. BIM, I'm not going to read you the definition, but I guess the key thing is that it's a physical and it's a model. It's a representation of the physical and the functional characteristics of a building. And the real key is that it's a database that can be used throughout the life cycle of the building. We're going to talk about life cycle a lot because I think too many of us as practitioners stop the day the owner takes the keys over. And integrated design, again, it's the interaction amongst all the disciplines. And again, through the life cycle. This is ASHRAE chapter TC 7.1, chapter 59 of the applications handbook, and includes operation of the total building. If you go to an architectural contractor, an engineering contractor, again, they most of the time stop at the end of construction. High-performance buildings, their definitions. I often worry about definitions that use the words in the definition. All major high-performance building attributes, including energy efficiency, durability, life cycle, etc. But is there anything missing from those definitions? I mean, those are big, broad words. Lawyers would love them because they're hard to define, right? But how about things like indoor air quality? I'm sure they're embodied in those words, but there's no definitions for it. Comfort, what's comfort? Visual, environmental, acoustic, indoor air quality. Anybody got any others that they, I mean, how might we define a high-performance building? A little feedback. User happiness. There you go. And I think we will tend to not focus as much on energy in the future as our rating systems and our codes more toward performance. And it's got to be all about people, right? Health, safety, welfare, happiness, cognitive ability, the effects of the building and its environment on your brain. Now, these are some of the rating systems. We all know them. I guess you all started it almost with Green, right? And all these are kind of children. One that's growing in popularity seems to be the Living Building Challenge, and the next level of that is then the Well Building Institute and its WELL certification, very specifically focused on indoor health and health, human health in the indoor environment. And these tools will have to morph and begin to do that kind of analysis, not just daylight analysis, energy consumption, thermal comfort maps, but be able to simulate what under many conditions, even disaster conditions, whether an indoor environment's tenable or not. That's why I asked kind of about the fire simulation earlier. Well, what's important about BIM is its information, right? I is the key. As you can see from this diagram here, that graphics, unless you're doing major renovations or additions to a building, they tend to stabilize. It's a great interface, just like a GUI is a great interface for a piece of software. But from day one, information continues to grow from the day you start operating a building and being able to use that. I learned yesterday from Dr. David John Gibbs up in Glasgow, and he presented on actually litigation associated with BIM that from some Facebook data that we're only using a little less than 1% of the data that's being generated to make any kind of informed decision. So there's a lot of opportunity out there, and there's a lot of noise. And building these tools with artificial intelligence and cloud-based engines to take advantage of that information to make better decisions will be the job of you students and researchers here in the room to help us practitioners find the easy button, right? Because as a practitioner, I'm wanting to crank out my designs and monitor my buildings and not be a coder, not be an analyst from the standpoint. I want to be able to interpret the reports, but I actually want to produce a product for my client and have trust in it. So, I mean, who are the stakeholders? Pretty much everybody. This person typically holds the gold, right? And drives the train. But sometimes having the conversations early enough and asking the right questions, having that checklist-driven design based on your experience, and I'll show you kind of my manual process right now before I go into any kind of BIM analysis in a minute. of what a workflow might be, and hopefully at some point will get automated in these tools. But here's our stakeholders. I mean, what makes a building unique? Every building is unique between its site, its envelope, its uses, its systems, but also its users, its climate, its region, the culture of the people using the building. All those things make a building unique. And you as a designer or you as a researcher have to understand that when you start developing these tools and working on these engines that can look at the various scenarios and come to those optimized solutions, or that series of optimized solutions, because there's not one, never will be one. Life cycle of a building, again, it's starting at planning, going through design, construction, verification. That's key. I do commissioning, but I can tell you that I've had so many texts and conversations with my colleagues back in the U.S. over the last 2 days on 3 university projects we got finished up now. And we've had, we started pre-design with the owner, with road owner's project requirements. We defined both envelope, indoor environmental quality, HVAC system design conditions, controls, interfaces, interoperability, and we're down to the school's got to be ready to be opened at the end of the summer. And after numerous meetings between disparate systems such as lighting controls, building automation, you still have people that will not talk to each other until the day they show up on site to start their work. So we've got a little bit of a cultural shift we've got to work through there too. Training. In BIM, I'll just use this as an example. In BIM, I see a lot of research going on. Some really nice things about how to use the data and do good things in BIM. I don't see many universities actually training a practitioner base to use these tools and use them well. And again, if we don't get to talk about it before I'm through, I'd like to have some conversation with you all as far as, and maybe at dinner tonight with my colleagues at SIBSI, as to where the universities are going with training our next generation of actual designers and the like. We should use continuous improvement process, was just plan, do, review, that's ISO. Now, BIM is a bunch of tools. We've been talking about tools all day, right? This is not proprietary. I'm not advocating one, even though some of my examples will use a tool, but there are a lot of good tools out there, and there are more coming online every day. I mean, when I started 4 years ago, we were using hand calculations and ASHRAE Handbook of Fundamentals and Solaire tables and things like that, and to run just a simple, 2-story office building could take you a couple of weeks to do sometimes. Integrated design is the end game, right? We want to provide a building that does what the owner wants, that satisfies those user needs. But why is that important? Well, owners don't like when things like this happen, or this. Believe it or not, that's an actual university dormitory, and that's not just one room. That happened in about 140 dorm rooms before the engineer, the contractor, the building official, or anybody caught it. It's right at the final inspection when the state engineer caught that somehow or another you don't put an electrical panel in a shower. All right, so what's our current process? As designers, we still work in silos. Everybody wants to do their job once, right? We don't want to spend any extra time. We don't care how many times you consider how to lay out the structure or the architecture or the lighting. The MEP guy wants to design the HVAC once. Our handoffs are poor. I mean, right now we still hand off things in a manual fashion 7 or 8 times in 7 or 8 different formats. And that's a tremendous opportunity for errors and omissions to creep in. and BIM and our software and cloud-based solutions can help us solve that. Current workflow for the owner. Meets with an architect. After that first 10-minute meeting, about 80% of the major decisions are made with no analysis whatsoever that will determine the performance of that building for the rest of its life. Okay? Materials, systems, orientation, look, siding, climate zone. And we have tools. You've seen them today, and I'll walk you through a workflow with one of them in a few minutes. Current workflow for the design team. The owner informs the design team, gives us a budget. Budget might be 5 years old if you're working on a federal project or a government project. Building doesn't meet it, it gets redesigned. Construction, same thing. We take the low bid in most cases, right? And the impact of value engineering decisions are rarely known. In other words, you'll see in a second what I'm talking about. I've tended to call it value elimination instead of value engineering because there's no engineering going on in those cases, right? And for facility management, we've forgotten them for a long time. So I'm beginning to see some research into facility management and integrating these tools into asset management systems and energy management systems and using some of the latest sensor technology such as wearables and things like that to get comfort maps, maybe a happiness map in the future. But the owner then ends up paying for it, and maybe energy is not the main thing we need to be concerned about. Maybe how we generate energy might be the main thing we need to be concerned about. So how might it look graphically? All right, so this green line here, I mean, this is our ability. I'm sure some of you have seen this. It's often called the McClamey curve. Patrick McClamey took an old civil engineer diagram and added something to it here in a minute at HOK. But this is our ability to affect cost as we go along in a project. And the further down that project timeline, and this works not just for construction, but any kind of project, research project, anything you're doing. Same time, the further down the process goes, the cost of changes increase astronomically or exponentially. And that's because once you've made decisions and they're set in stone and people have committed to the work and produced a work output or a work product, going back and changing it is expensive. And people tend to rather stick to it than admit that maybe something could be done better just to get a project done in some cases. And so this is our traditional process. I mean, we let that architect and owner meet just for a little bit early in the job. And then right toward the end of DDs or construction documents, we hurry up and get it done once. Project comes in over budget. We have to put a lot of effort in to get it back under budget, and then things settle down for a bit. And then we get the value engineering list from the contractor. And it's usually just a checklist, and it's handed to the owner, and he just starts with the biggest impact, the things that take the most money out. And without much engineering or any kind of consideration for the impact, a lot of times things get missed, right? And that circle was just in case you didn't see that. All right, so what we want to get rid of is this, right? We want to get rid of the value elimination hump in that curve. And how can we do that? We can move that analysis earlier. And to do that, rather than, when I first started, after I got to the point that I've had a computer that could run loads, it was fill out a book, take it to a computer center, get punch cards run, mail it 1,000 miles away, wait a week, pay $2,500, get it back, and hope you didn't have an error, right? So it was a long, drawn-out process. So again, you wanted things finished. You only wanted to run it once. Now we've got tools that can run in the cloud, run those optimizations, can run millions of iterations. So why aren't we looking here early? In the what I would call the optimum or optimized value engineering location of where we ought to be thinking and talking about making decisions, informed decisions, and understanding what the uncertainty is in those things. So value engineering ought to be about making informed decisions. That's where BIM, integrated building design, and the processing power of our computers, our technology, the cloud, parallel processors, and smart experts like you all in this room. Iteration of design can meet the budget. It can have cost built in, whether it's from a cost database or past experience. People say, well, BIM can't be used on a small project. Well, if it's a small owner, even if it's a strip shopping center or an office building, if there's turnover, BIM's valuable because you've got an accurate record of that as-built condition. And you don't have to go out and survey and measure that building every time you want to move a new tenant or somebody in and out or change or adapt a space, say, from an office to a data center. If you've got good data in that common data environment. Lifecycle cost is a key. Comfort, lifecycle cost, finding those optimization, that Pareto curve, as you defined it, finding those and finding them fast is where we need to be working toward. As an engineer, I think Andrew and I were talking at the break. Andrew has spent a lot of time talking to architects and engineers about adopting new tools. And sometimes he was frustrated just because they wouldn't try something new. Well, I'm coming up on a little over 60 years old, done a lot of things the same way over and over again, and you get comfortable. You know you're not going to get in trouble if you're using something. So it's hard to get people to move off dead center and try something new. If I'm going to put my stamp on a set of drawings and expose my employees and my errors and omissions insurance carriers to some risk, I have to trust that these tools are giving me the right answers or answers that I feel confident in. Again, going back to those early days, before we did calculations, on a whole building, we'd run a few rooms. We'd use rules of thumb. When we got those first computers, what we did was sometimes run those things 10 or 15 times until we got an answer that agreed with our rules of thumb. It took a long time for us to stop putting safety factors in and trust the output of those first software programs that did heat load calculations and energy calculations. And that's where we are today. And unfortunately, I think technology is probably ahead of the ability of designers to, one, afford those tools, the majority of the designers, and then two, absorb it and put it in without some good training. So we are at a crossroads between doing things in 2D as designers and moving into a multi-dimensional virtual work environment. I used to say 3D, and I changed that because we've moved beyond drafting. 3D to me just kind of gave the connotation that we're still just using these tools for drafting, and we're not. We're having to use these tools to demonstrate compliance, human comfort, human health, and those are the most important things, and those are multidimensional and go well beyond the physical characteristics of materials and spaces in a building. So here's a workflow that served me well. I'm going to use ASHRAE documents and ASHRAE resources, but you could use SIBC and any other organization that produces a set of reference documents for whatever discipline you might be going into. If I were charged with, even today, before I ever get into my virtual environment and start using a BIM or start using one of my analysis tools, if it's and I've seen a lot of projects, worked on about 4,000 to 5,000 projects in 40 years. I still go back to my resources if it's something I haven't done in several years. And I typically will start out with the HVAC applications book because If it's a hospital, if it's a museum, if it's a data center, I can go to one source, read through what the pros, the cons, the types of systems, the things I need to consider. So I can get a basic understanding of how that particular type of building might work and might function, and what systems might be best to be applied to it. Once I've done that and I understand the building and what systems, I go to that systems manual and study those systems, okay? And understand what are the pros and cons. And do I understand, can this owner operate it? Can this owner maintain it? Those kind of things. Then I go and look for current data, right? So I start looking at my journals, whether they be research journals, ASHRAE journals. If it's specific to the building or the type of application, operating room, whatever, clean room, I try to educate myself, again, before that first meeting with the owner and the architect to learn about it. And then finally, go back to the fundamentals and understand what kind of calculations and analysis need to be made. And that's before jumping into anything. Software documentation these days, a lot of times it's either hard to find or it's online, and if you don't know what the engine's doing, you're never going to be able to have trust in its output unless you've run it a lot of times and then had the experience of making the systems work in the field. So let's move kind of into this digital environment. Not many of us work this way anymore. Anybody do everything, right? We all have to work in some type of collaborative environment these days. And in most cases, if you're a design engineer or a design architect, there are a few big multidisciplinary firms, but the average size firm in the world is 5 people, construction or design, and in most cases very discipline specific. So you find yourself having to collaborate with multiple firms and multiple offices in many cases. And that's where your expertise, your little boutique is valuable to a team. And then some do work in this environment with and with BIM, you know, a central model, a server. But we're very fast moving toward a work environment where we're all going to work in a cloud-based parallel processing environment. In fact, some of the tools, the Revits, the ArchiCADs, the Bentleys, they're moving toward obsolescence, and their next generation is going to be really just a common data environment, kind of like Google Maps. I don't know if any of you saw an AEC article not too long ago about next generation design tools, but the data, just like a Google Map or an Uber application, data resides where it's most appropriate. And then it's linked together in some type of common data environment so where it can be used in the applications, whether it's fire protection engineering or mechanical engineering or electrical engineering or architecture. That application is there on your, not necessarily your desktop, but just running in a browser, accessing only the data it needs so it can do the analysis you need in a reasonable amount of time. So I'm going to talk now, I'm sure you've seen this workflow today, so I'm going to talk about kind of one way that we've done optimization and helping some clients through Design Assist. But this is kind of the life cycle of a model, right? I mean, you've got a concept, usually starts out in a mass. Schematic designs start looking at facades and things like that, and then finally at the construction or tender phase you create detailed documentation and then move on to the operations phase. So let's talk. A lot of the BIM tools are coming now with analytics built in, integrated tools, heating load calculations, energy analysis, renewable energy, daylighting. There's lots of other things that need to be added, just like I said, acoustics, visual comfort, thermal comfort. But normally that starts out with something like a mass, these things can be created. You can sit down with an architect and an owner and a design team, and just within an hour or so, if you've got either an architect or engineer that's good with a sketching tool, a massing tool, add some floors, and actually add context. You can bring in those cityscapes and use the surrounding terrain as well to see how it's going to affect the building in its context. You pick a location, and right away you start getting results. And that can be in your energy unit of choice, or CO2, or dollars, or currency. But here is some of the ways that these tools quickly start keeping up with things and defining some of the uncertainty here. And I've gotten so used to using a touch screen that this is, hang on, here we go. All right, so again, this particular tool gives you, if you'll notice, there's a range depending on the variable you're looking at. Once you can drag this thing down to a narrow window, or you can open the window up to multiple variables. And as you do that, it's constantly calculating, again, what's your lowest possible energy consumption or cost, and what's your maximum based on the range within the variables you're looking at. And there's numerous ones of them. And if you want to add a benchmark, if you're trying to design something, say like an ASHRAE 90.1 2007 or an architecture 2030, this can keep up with your changes and give you a range of expected results. So you start thinking in uncertainty and possible ranges, or you can show an owner this and say, well, but maybe if you leave infiltration, if that's one of the variables you're looking at, maybe the contractor's not going to really build this building as tight as we think it will, or those kind of things.
Just gone through 8 minutes to go.
Okay. Well, then I'm gonna scoot. So you keep up with your history. You can go back and compare different masses to one another, different operating schedules or ranges of operating schedules, and percent glazing, shading, solar PV, payback, those kind of things. And then these are the kind of results. Going through, again, I am trying to work through a workflow where I stay in or use the minimum amount of tools that I need to do the job right, and feel confident that I can put my stamp on and do engineering in these tools. So what might I do? I might define some spaces, create them, define my load parameters, which would be all the functional characteristics of my materials and rooms and spaces. Review those details, drill down, see if I've got any gaps in my model as a workflow, and then calculate my loads. And this is just a little blow up to just show that, hey, it's an Energy Plus engine, DOE2 engines, they're good, trusted engines in the background, running, and they're producing outputs that we see every day from some of our other standalone tools and our integrated tools. And then finally, when you get into design, once those are run and that data is stored in the space it's associated with, the way I used to do it manually was I'd lay out my air distribution devices. And I'd locate my equipment. Then I'd start connecting the dots and sizing things. Well, these tools can now start connecting these dots and sizing things for you. And using ASHRAE Handbook of Fundamentals, and thermodynamic algorithms that we've used in school and our whole career, just as long as you understand what kind of coefficients and what variables you're using in the software. Place your pipe. One of the things I like about this tool is the things I don't have to do anymore. So, I mean, I don't have to cut sections. I can create a section. I can expand sections. Nothing has to be hand-drawn once you've placed your systems in. We've got properties that some get calculated, some get manually input. And I'll skip through. Schedule generation's another thing. I mean, Schedules are important, not just to go on a set of tender documents or bid documents, but I create a lot of schedules that I use just for design. Areas, volumes, lengths of pipe, pounds of ductwork, those kind of things. So there's a few documents. Let's talk for a minute or two about codes and standards. This was an introduction. It's available for free. It's a little old, maybe a little dated, but it's still got some good processes in it. I'm going to leave a copy of this here so you all can get it. And there's actually 101 slides with notes in this deck, and I've hidden a lot of them, so you feel free to distribute it, with all the slides turned on. Worked on this. This is called the National BIM Guide for Owners. Very similar to some of your past 1192 documents, where we are beginning to, and this is hopefully will move in this summer to be written as a standard that explains to an owner what's the minimum viable amount of information needs to be in a BIM for it to be useful, and how to ask for that and write that into a contract. It's written for the owner, and it's to cover all phases. Doesn't talk much about intellectual property. That's still a sticky situation between the legal and contracts. We've got commentary that explains why things are done, and then we've got guide language on how to get those requirements of what you want in a BIM, so you don't just so an owner doesn't pay for things he doesn't need. ASHRAE 90.1, the big changes in Appendix G can be used for compliance path. One big change is it requiring, as well as LEED version 4, if any of you work on LEED, ASHRAE Standard 209, which hopefully will be approved as a standard after its third public review this summer, requires at least a shoebox model, that massing phase model, be run, and a written report to the owner be given on how that was used, how these simulations were used, this performance analysis, to inform the design. So that's a big step forward in moving this modeling earlier in the process for us to push our technology to be more useful. I'm going to skip through some of these that, today we're focusing on what we can do with the information. We want to seat at the table earlier. We want to stay longer. We're trying to learn the tools the best we can and use as much of the tool as possible, and going beyond construction, staying with the job for life cycle. I'm going to get through these because I want to, real quick. Future's already happening, of course. Anybody doing integrated spec writing? Or BIM to fabrication and BIM to simulation. We've talked about some of these things already, so I'm going to move through them because I want to get a chance to. But the process is you all, and that's where the most work needs to be. How to use these tools, how to integrate these tools, how to combine these tools to do a good job at producing great buildings and good human environment, great environments for humans to live in and work in and play in. All right. Some of our barriers, again, even though we've talked about interoperability and integration, those are still our biggest barriers to success right now. We do need open source solutions. The handling of information, consistent application of the technology. So its impact on ASHRAE. Well, ASHRAE, I showed you those ASHRAE handbooks. We're working toward creating smart XMLs and rule sets so those can be used, put in a common data environment, and be accessed by a developer through an API or whatever, so that if I'm doing a design and I do something that's at variance with an ASHRAE standard, I get an alert or a notification, almost like spell check in Word, that says, hey, you might want to look at this again, that you've done something that doesn't meet 62 or 90.1 or ASHRAE 55, something like that. And we've got a lot of our handbooks and TCs working on that. Real quickly, here's some of, our resources, if you haven't gotten a chance to look at some of the things like the National BIM Standard, Indigo, all of this needs to be harmonized, I think, to some extent worldwide. So we need to be talking to each other. That whole building design guide's a great resource for anybody working on buildings. ISO, again, if you go to ISO and just TC59, search for BIM, there's 6 pages of standards and technical activity on building information modeling standards and data exchange. And of course, you all know about these. These are mostly yours. I'll be interested to hear how they're working, especially with some of your mandates, BIM Toolkit, and others. So how do we harmonize all of this, and should we? And maybe I'll just, I'll come back to this one, but I like to say, you know, I used to say EUI, energy use intensity, but energy used intelligently is what we ought to be thinking about. And more importantly, with a focus on a human being, resources used intelligently, right? That's where our minds need to be. And our end game needs to be looking at making our decisions better, more informed, and earlier in the process. So let's go back here. If we want to do our Q&A from here about how we harmonize this and should we and how might that happen. I'm really curious in your feedback.
Well, I think that's been absolutely fascinating and raises quite a lot of questions for our industry moving forward. Well, anybody got particular questions for Dennis, just to kick off with?
It's not a question, maybe a comment. What do you students think? What's the future of our industry? Yes, sir.
Well, I'm visiting from the University of Queensland. We have a multi-million-dollar advanced engineering building.
All right.
And, you know, it was all talked out to be wonderful and that we could have our students learn how to use it. But it's really hard to actually get the models from the architect, because you ask and you get PDF plans, you know, who tries to build a model with IES or whatever. You know, we paid a lot of money to have this thing commissioned, and then to have the continuation of using this building, to continue to learn about it. Somebody's got a model somewhere, but all they send around are PDFs of plans, you know?
And not smart PDFs, at that time.
Yeah, they're just flat plans. So then you got to spend just endless hours pulling out your hair trying to figure out what does a cross-section of the building look like, how's it put together. So that's just an example. You know, supposedly a smart state-of-the-art building.
Right.
And they said, oh, we're going to be teaching and doing research in this building and understanding all the wonderful features of it. And we have BMS, not BIM, but BMS. We've got smart display in the lobby showing all these trends and what the solar panels are doing, but it's really hard to just remodel the building. So I just thought that was an interesting example to throw at you.
No, I see it all the time. We have, and when we do get models, they're not as built, right? They've not been verified. I'm seeing a few commissioning agents start having contracts to verify the models. Do you know, well, I'd start asking some questions of whether the model was even passed on to the contractor to be used, or if the contractor had to generate their own model for coordination. And maybe ask your procurement people what was the deliverable in the contract. Because normally, I know with the universities I work with and the K through 12 school districts, we require those models to be delivered. We have not yet required anybody to make one as built at this point, but it's coming. We have had them put COBE data, or at least put manufacturer model number, serial number, tab information, that kind of thing in the models. But as far as it being an accurate representation of maybe where every single valve and pipe is, but that's a deliverable. I mean, that's part of the systems manual and the commissioning process, is to at least get it and deliver it to the client. So it's kind of like plans and specs. I mean, sometimes it's hard to find them. So I mean, go to procurement and see if you can find out if it was in the contract to be delivered to you. And, yeah.
I mean, I'm kind of, I mean, it's interesting to me that, you know, the same problems that Dennis is seeing in the United States are pretty much identical to the same problems that we're seeing in the United Kingdom. And I guess these are the same problems that are worldwide.
Well, I've done this in Thailand, I've done this in Hong Kong, I've done this in Taiwan, I've done this in Indonesia, and then most recently in India. And we all think everybody's doing it better. We all think that. And when I go to a room and there's 100, 200 people in the room, and I can usually maybe find 2 or 3 hands if I ask, well, who's using them? You know, maybe 5 hands go up. Well, who's using them to do engineering? 2, maybe 3 will stay up. Anybody doing specification writing? No hands. And 9 times out of 10, nobody's doing anything from the operations phase. So it is a common problem, and I think through our inter-society collaboration, we've got to change that culture, because these design tools are moving well beyond the capability of the average designer as far as their technical power.
Do we have a view?
Have you considered the issue of contracts and liability? Because I think that is a key issue that needs to be overcome before you actually put things in action. Because you do see professionals resistant to share modules because of that reason, and there is protection issues related to that. And,
all right. Yeah.
and so I think if we don't think about liability and contracts, we will never move on, because that's where that is a big barrier that needs to be taken into consideration.
If we don't move beyond contracts that are adversarial from day one, in other words, I like to use an expression, and AEs do it all the time. I mean, we're risk averse, and I say don't execute a contract where you agree to be executed, right? So if you're turning over something, it's got a bunch of garbage in it. One key point yesterday about that 1% data, the 99% that's not being used. Well, I can tell you who's going to use it and who's going to use it against you. It's the forensic engineers and the forensic attorneys, because that model is going to be full of data that you don't even know is in it, right? You grab something off the internet, you grab something from a manufacturer. You know, 8 years from now, you're never going to be sued on a project. A year from now, when you remember what you did, it's going to be 8 years from now when those brain cells are all gone, and you have no clue what was in the model, much less what you did with the data, okay, unless you've got good documentation. So we've got to change the way we write contracts. We've got to be very specific in these past documents and these building owners' guides as what's the prescriptive minimum amount of information. If I were going to give an owner a model, I'd probably scrub out most everything but geometry, you know, unless I knew, or the actual tab data and the manufacturing model number. I'd scrub out anything else. I'd run some type of script to clean that model up as much as possible before I gave it to an owner. That doesn't mean you don't have 10 versions of it sitting on a server somewhere with God knows different information in every one of them that could be used against you again. I mean, it's a cultural thing. We've got to, again, that common data environment I think will solve some of that, because we won't be delivering different information in different formats to people. But that's a tough issue. And I can tell you, I mean, the young attorney that presented with me yesterday, he's got 150 experts sitting in a firm. The first thing they do under discovery is ask for the models. And they start, you know, and it doesn't have to be anything to do with what you're being challenged on or what a complaint is. But back when I did forensics the manual way, I mean, I go through a set of plans, and I can still do it today. I can find 5 errors on every single sheet in a set of plans minimum. It might not have anything to do what the legal complaint's about. But I'll walk into a courtroom, and I've got 100 drawings with 500 circles on it. I've immediately discredited that design team, right? Nobody has faith in anything they did on that job anymore. So they're starting in a bad position. So, yeah, we have got to work on our contracts and the way we're willing to collaborate and share information. I mean, that to me is really the biggest elephant in the room.
And I guess that applies to sustainable sort of simulation as well.
Absolutely.
Because if we're going to be advising architects, you know, to change the window elevation or change the facade or, you know, put more mass in, all of that means that we're stepping out of our normal cozy discipline of, you know, comfort design, as it were, and stepping into structural engineers' domains and architects' domains to influence, you know, what ultimately they're doing. Go for it, Ian.
So why does Scandinavian countries do it better? There said, 50% the project is here. I guess
So why do
Any
Scandinavian
of you guys
countries do
gonna
it
tell us,
better?
what you think? Somebody going to tell us what you think?
Well, I guess I'm being quoted here. I think that one of the key reasons is that there's much less regulation. Much less, very much less. And that's an enabler.
Well, I mean, the goal is this stuff's supposed to reduce litigation, right? But I don't think CAD or anything else has ever done that.
I agree completely that you're responsible for every number in that court situation.
There's a question up at the back here. Just let me get the mic up to it.
Yeah, it's not so much a question as an observation.
Sure.
I think what I'm hearing here is what we all see and hear so often, and I would just say caveat emptor. You know, we've got into a scenario where the supply chain is expected to take on all the liability and responsibility, and we need more intelligent clients. I think usually we find enlightened clients are those which come into the business. They've built buildings before, they know the traps and the problems and the issues, they know how the construction industry works, which in my view is an absolute disgrace in the UK and probably around the world as well. And it's that thing is, if you expect things to change, but you're going to carry on doing them the same old way, that's the definition of insanity. So I do feel, although it's very drastic, there needs to be a reset in the industry. You know, instead of governments telling people we're going to control energy costs, they need to be telling the suppliers to control how much energy buildings use. You know, the Australian NABERD system, to me, sounds very good. You know, the Scandinavian issue where you have to guarantee the performance of the building, much like the VW scandal and everything else. You know, there's all sorts of issues about how you're going to demonstrate and prove these things, but I think you have to take it back to the client, and get the lawyers out of the room.
Yeah, we need tort reform, you're right. And an owner, they own the asset and they're the only entity that's in a position to recover any kind of loss, right?
Yeah.
So realistically, there should be contingencies built in, and we shouldn't let them be value eliminated out, right? It's part of the uncertainty profile of a building should be that there's contingency in it. And,
Project insurance, you
Right.
know, if the client's that confident in the team he's selected, it's with health and safety, CDM, everything else, the client has to take responsibility.
Right.
Do that with the rest of the design team.
Agreed.
Design
just need to get back to the scenario where the industry has got standard terms of appointment, fee levels, because that's half the problem. People just haven't got the money to do the job properly.
That's right. That's right.
I got a mic, so I might as well ask the question. Keep the lawyers out of the room is the thing that I'd like to link to. I did a consultancy job for a client that involved use of new material, hemp-lime biocomposite, for which there's no simulation tool that can actually model it accurately. And I came up with an additional analysis, post-processing, that involved some heavy maths, Fourier series and so on. And I showed to the client that actually, if they listen to me, they will save 2/3 of the M&E costs. But it might not work because we haven't done it before. They have to take the risk. And they did, and they actually did save 2/3 of the M&E costs, and the building performs wonderfully. So I think we need to change the contracts, we need to change the way how we operate, because otherwise nothing new will happen.
And you are willing to have that conversation with that client. And we've all got to be willing to have those kind of conversations. And, what's going to happen? And usually the right answer is, it depends, right? So, the client needs to be assuming a lion's share of the risk and the responsibility for the outcome of the front. And that's, again, why that early phase work and documented, that owner's project requirements, but then a basis of design that responds to it. And that owner was in the room when the conversation that took place, or there's a report that explains that uncertainty. And, it's a big industry to change. Just even in our small discipline, it's a big industry to, move the ship, or turn the ship, right?
So I think that's about us as professionals having a little bit more confidence in what it is we're doing, and maybe being a little bit braver about what we suggest that other people do. And we have these tools to help us, to inform and to give us that little bit more confidence if we only use them a little bit more and take stock of the absolute. I mean, the computing power that we have at our fingers now is way beyond anything that we've previously had. And we can see that there are things now that are happening in other industries, and that's one of the things that I'd kind of like to connect the simulation industry with. There's the aircraft industry, there's the automotive industry, there's the health tech industry. All of these guys are using simulation tools as well. And somehow we never seem to get a connection between the construction industry and what these guys are doing. And in some senses, they've been grappling with the same kind of problems that we've been just talking about today, and maybe solving them, a little bit better. Maybe they haven't got quite so many partners involved, but most of these things, aircraft, cars, they've got components that are manufactured from all over the world and pulled together very, very succinctly and very accurately into a finished product. And I guess that's where we need to get to in some senses. I don't know if that's a convenient place to draw this to conclusion today. I was supposed to give you 15 minutes talk, but I'm not going to do that. It's very good that we've had that conversation. But what I would want to do is to thank Dennis for your contribution today. It's been absolutely fascinating. I'd like to thank all of the other speakers and sponsors who came today. I won't sort of say who you are because I'm bound to miss out one. I'd like to thank all of the audience, you guys that actually took the trouble to take a day out of your busy lives to come and listen to this. I hope you found it as fascinating and as interesting as certainly I have. And what I do hope is that you take a little bit more interest in ASHRAE. We've got some fantastic plans going forward. We're just about to set up our first UK chapter, which will be ASHRAE UK Midlands will become a chapter. There's a section being set up in Glasgow, and we're due to set up another section in Manchester in the not too distant future. And that goes together then with what's already happening, I guess, in the southern end of the country, which is the CBC ASHRAE group. And hopefully, well, I think it's already been signed that we will have an ASHRAE Europe region, which will be operative from July.
It's absolutely been
That's been
voted
ratified
on,
now.
approved, and you're on your way to being stood up as a new region, right?
So all of that makes ASHRAE a lot more proximate to us and gives us access. Well, maybe we're going in the opposite direction to Brexit, that we'll actually start to forge some bigger and better relations with our European counterparts. And I don't think that will be any harm. So with that, there's one special person that needs to be thanked today, or maybe two. And they're both sitting here in front of me. So if you two guys would like to just stand up. So we've got Yi Zhang and Lubo Yankovic, who are responsible for the organisation of all of this today. So I'd like you to give them a round of applause.
I'd also like to thank